Please. Well, sure. I have a terrible case of imposter syndrome, which I'm trying to get over in these hallowed halls. Before I say a few words, introduce the panel. Oh, hello, there's Stevan Harnad, who we can see in front of us and who you can see behind us. That's wonderful. So, as Wendy alluded to in the before, Sir Dermot Turing, who was going to be joining us, is not with us because of travel problems, but he will be joining us later. We hope very much. And so I'm very happy now to introduce our panel. We're going to discuss the Turing test from a historical perspective. And when I was thinking this morning if I could say two sentences before we started. One was going to be the difference between the natural sciences and the humanities as I was taught to understand it many years ago. And the difference is that I'll assume that most of you are more denizens of this place than the one across the way. You're in the business of explaining things, explaining the natural world, and drawing conclusions from that explanation in order to make the world a better place. One hopes. And we in the humanities, I'll leave the social sciences out of it because it's complicated, contested ground. We in the humanities are in the business of understanding things. And one mode of understanding is historical storytelling. And I must say, to my delight, there's been so much storytelling. There was a sessions this morning and so much storytelling already now. And so we're going to continue in that vein. And we're going to do that together with Professor Sarah Dillon, who is Professor of Literature and the Public Humanities at Cambridge University and is currently working on a book called Turing's Literature. And this is fair. And she also, it comes with there are props. Stevan Harnad, who joins us virtually from Canada, is an emeritus professor from my place, from the University of Southampton, a very distinguished cognitive social scientist who I believe needs no introduction here in this room, and has a long-standing interest in the Turing test. And then, to our great delight, when we heard at lunchtime that Dermot Turing was unavailable, Peter Millikan has stepped in. He's had about an hour's notice. He is the Gilbert Ryle Fellow and Professor of Philosophy at Hartford College in Oxford, and he introduced a degree in computer science and philosophy there in 2012. So we have Alan Turing in our place as a statue, and for you, he's the poster boy, you said. And you've been teaching undergraduates or people on this course about Alan Turing and the Turing test ever since. So without further ado, what we organized was that we would each get a chance in alphabetical order to speak for 5 minutes about the paper and its historical understanding of it. We'll start with Sarah, then we'll move on to Stevan joining us virtually, and finish with Peter, whereupon Alan, if he feels so inspired, can also say something, and then we will devolve into some more free conversation. Please, Sarah.
Brilliant, thank you. Well, Turing's PhD student and friend Robin Gandy would be really annoyed that we're all here today. He wrote in a wonderful essay that I discovered this morning, was in a collection that Peter edited, so that's wonderful, that he saw that although Turing did believe that there was no reason why computers would eventually be able to do all the things that human minds could do, that this paper that we're talking about today was nothing but a piece of propaganda. And he spends the first paragraph totally dismissing computing, machinery, and intelligence. Turing, he said, was just trying to get attention. He was trying to get mathematicians and scientists and philosophers to take computers seriously and take what he talks about in the paper as imaginable computers seriously, as in what they could do if there was enough investment in them. And Gandy also remembers Turing reading the paper aloud. He said he wrote it quickly and with enjoyment, unlike his mathematical papers. He read the passages aloud, always with a smile, sometimes with a giggle. And his very last sentence is, "Some of the discussions of the paper I have read load it with more significance than it was intended to bear. I shall discuss it no further. And yet here we are, 75 years later, sorry, Robin, still discussing it. And I'm curious as to why. We're not, or I don't think we did, have a 75th anniversary of Turing's paper from 1937 on computable numbers, which is actually the most important paper, mathematically, scientifically. I'm very glad you're nodding, because that's where he comes up with the theory of universal machines. We didn't celebrate that. It's not a very catchy title on computable numbers. I'm not even going to try the German bit. And it's also really dense. If you're not mathematically trained, it's actually really difficult to read. However, Computing Machinery and Intelligence, good title. It's sticky, as we say in policy circles. And you can read it even if you're not mathematically trained. It is in a philosophy journal, not a science journal. Now, sorry if I'm going to offend philosophers. I am trained as a philosopher as well, but it's not what Turing would have considered a scientific journal, mind, and it certainly isn't rigorously philosophical. In fact, any of you who've read it will know that it's really weird. It's incredibly illogical, it's incredibly inconsistent, and it gets stranger the more you read through it. And Bruno Latour, who's a philosopher of science, he calls it the most kitschy, bizarre, baroque text ever submitted to a scholarly journal, and even goes so far as to compare it to the Alan Sokal hoax, which I won't go into, but some of you will be aware of. So when Wendy gave us the wonderful task of explaining what Turing meant, I was like, brilliant. How do we do that? Not least because we were also told we weren't allowed to use the thing Turing invented, as in we weren't allowed any slides. So I have enlisted what in Intelligent Machinery, which was Turing's report for the National Physics Laboratory 2 years prior to the Mind article, paper machines. I have human beings, and they have pieces of paper, and I have given them instructions. Now we'll see whether paper machines work effectively. No pressure, guys. So what I want to do is just very briefly point out something which I don't often hear said about the paper, which is that, of course, Turing doesn't talk about the Turing test in the paper. It would be weirdly narcissistic if he did. He talks about the imitation game. But there isn't one imitation game. There are 7 imitation games in computing machinery intelligence. And if you add the imitation game that he talks about at the end of the MPL report, there's actually 8 imitation games that Turing imagines. So very quickly, the first one, are you ready? Yeah. We've got C. So, Stevan, you're involved in this even though you don't know you are. You are C in Turing's test, which is the interrogator. You are at a remove from the participants. Really, you shouldn't be able to see us or hear us either, but we're not going to mute you and turn your camera off. And then we have A, which is Tom, and we have B, which is Peter. And these roles change through the different imitation games. So in the first one, Tom is a man and Peter is a woman. And Stevan has to guess which one is which, and both are trying to deceive. In the second version, so one of you keeps your, see, we're failing already. One of you keeps your thing up. Well, we'll keep going. In the second version, we've still got the man and the woman, but the woman is being herself, and it's only the man who's trying to deceive. In the third version, Tom gets replaced by a machine, and he has to try and convince Stevan that he's a woman. And it's only in the fourth version that these two become non-human. And we get a digital computer, Tom, who is trying to imitate a discrete state machine. And it always passes, this version, because Turing's point was that computers were universal machines and that they could always imitate successfully any discrete state machine as long as they had adequate storage capacity, they could work at sufficient speed, and they were reprogrammed afresh to perform whichever discrete state machine they were imitating. It's only in the fifth version that we get to the imitation game that we might think of as the Turing test. Here, Tom is a digital computer, but he's not up against a discrete state machine. He's up against a man. I'm not sure why it's not a woman, but it has become a man now. And it can pass the test under certain conditions, and these conditions are inherent to the computer, so it needs storage speed and programming. They're inherent to the situation. Stevan can't see or touch or smell or in any way interact physically with Tom and Peter, and to the nature of the questions, which had to be simple yes or no or mathematical. And Turing thinks that eventually, you can put them down for a little bit now, it would be possible for a machine to be able to deceive. So the question that's most important, and I want to leave you with before I pass on, is what does passing the test, as Turing imagines it, prove? And what it proves, and the clue's in the name, it proves that a machine can imitate some of the intellectual operations of man. That's it. It doesn't prove anything else. And if we think about it as proving other things, we're in the problem of what's called construct validity. Does the test measure the thing we're actually saying that it's measuring? Whether it proves something else depends on whether you believe that the question, can a machine think, is equivalent to the question, can a machine win the imitation game? Not even Turing thought that actually those two things were equivalent. He opens by suggesting they are, and at various moments throughout the paper, he actually backtracks to the point where he says the question of can a machine think is too meaningless to deserve discussion. So that's what I want to leave you with. And you've got your last two sheets just for completion, because if you're like me, you're like, what were the 6th and 7th versions? The 6th version is the structure of an academic viva, but it doesn't work because you actually haven't got the comparative element, so the analogy doesn't hold. And the last one is where the digital computer is up against a telepathic interrogator and a telepathic man. And the only way to safeguard this experiment, according to Turing's paper, is to put them all in extrasensory perception-proof rooms. I'm not kidding. This is actually in there, in the text, but I think it's important to remember that, although I'm not kidding, Turing was quite a lot of the time in this paper, and we need to be very cautious what we take seriously from it, how and why. Well done, guys.
I was a bug in the code until I understood the instruction. Without further ado, while we digest that, I would like to move on to Stevan and ask you to give us 5 minutes reaction.
Thomas, I have to ask you something. Are you willing to give me the dispensation, because I'm so far away, to display my notes so that you have something to bear in mind?
You can do whatever the technology will bear.
Okay, let's see if this works. 1 second. Just a second. This should share. Are you seeing this? And when
Yes.
I put it on, and now when I put it onto its,
Yes,
just a second.
nearly there.
I want to have that displaying sequentially. Now the question is, how do I get the?
So you need to.
I have to
Slideshow
make it
down
into
below. That's the
PowerPoint
one.
mode. This will be it. Okay.
Wonderful.
Now, I want to start with something that the literati will recognize. And by the way, please, Thomas, be brutal with me when I exceed my 5 minutes. Cut me off.
Okay, I'm looking at the time. Yep.
The William Wimsatt has the celebrated notion of the intentional fallacy, which is you're making a mistake with Shakespeare or anyone else. Oh, goodness. Okay, I had to cut off that phone. If it was Shakespeare or anyone else, you're making a mistake if, in order to try to get the meaning of the poet from what they've written, is to try to guess what it is that they meant to say. That's the intentional fallacy. This is one of those impromptu things where you can't stop people from phoning you over and over again. The intentional fallacy is to assume that you're trying to guess the poet's real intentions. We're trying to guess, it's not a poet, we're trying to guess or second guess what Turing really meant to say. But the intentional fallacy is even more complicated than that, because according to William Wimsatt, even the poet is not, oh my goodness. Even the poet is not the authority of what it is that they meant. You have to figure it out for yourself, in a sense. And I think, although I never tire telling my students that I am a Lilliputian, and Turing, whom I admire without reserve, is a Brobdingnagian, way bigger than the rest of us. So in second guessing his intentions, I don't have any pretensions that I'm right, but I want you to hear what I think. I think that the essence of Turing's playful paper was the notion of Turing indistinguishability. All this business about men and women and etc. is irrelevant. The only thing that is relevant is not being able to tell the candidate apart from any other person. That is an extremely exacting criterion, Turing indistinguishability, and I think it's equivalent to empiricism. I think what he was doing was in fact anticipating a new science which has since been called cognitive science. Why was the original Turing test focused on language? Because language is bigger than life. We can say in words just about anything that we can think, perhaps everything that we can think. So something that can pass a test that makes it impossible to distinguish it from a real thinking person in any interaction. I don't think it's people passing notes under the door that matters. It's in fact what you could do texting with somebody for a lifetime. Why were the man and woman out of sight? Just so that you would not be biased by their appearances. What we were trying to test here was a capacity, and the capacity was, in the original Turing test, a verbal capacity, the capacity to speak and interact verbally indistinguishably from any other person, to any other person. How long is this Turing test supposed to last? This sounds ridiculous, but in fact, in principle, it should have the capability for a lifetime. Because what's the point of doing a game that tricks people for 5 minutes? Was Turing a computationalist? Did he think cognition is just computation? Cognition, which by the way, he talked about intelligence, that I never tire of saying is a weasel word, but cognition just means thinking. People think, and we assume that they do things because they can think. What was his mistake about solipsism? He used the word solipsism, but that's not what he meant to talk about. He wanted to say, my test can only test what people can do. It can't test what you can't see and you can't hear and that's going on the inside. So it doesn't touch sentience and feeling. What would have been Turing's view on the robotic version of the Turing test, which is not just computation? I don't think Turing was a computationalist. The Turing thesis is that computation is extremely powerful and can do anything that a mathematician does when they're computing. But Turing himself didn't say that thinking was just computation. He would have admitted that what I call T3, the robotic version of the Turing test, and even perhaps T4, which is the inner side, which is what's going on inside the brain. Is imitation, is the Turing test imitation? No. He used the word over and over again, but it's not. Is it a game? No, it's not a game. Is it what it takes to pass the Loebner Prize? No. He explicitly said it wasn't a Gallup poll. You're not taking a vote. It is, in fact, a bona fide empiricist attempt to reverse engineer cognition, reverse engineering the capacity that all thinkers have. And the easy and hard problem of cognition, which is the capacity to do what we can do versus the capacity to feel, which is sentience, and what he was indirectly alluding to when he spoke about solipsism. The easy problem is the Turing problem. The hard problem is has been ruled out of court by Turing. He says, I can't deal with that. And he doesn't, I don't believe he believed in telepathy, but he was joking about that sort of thing. Are LLMs, large language models, cheating with their superhuman big gulp database of human discourse? Yes, they're cheating, but they're passing the Turing test. If you're not a computationalist, you say, whatever wherewithal you use, that's if you can do it indistinguishably from a real human being, you've passed the test. And I think anybody who's given ChatGPT and Claude and Gemini a run for their money has had the same feeling, and it's a feeling, that you are interacting with something that's understanding you. it's false. It's not understanding a thing. And the reason it's not understanding a thing, I haven't got time whose last theorem, who was the mathematician with the last? Yes. That I haven't got time to discuss here. I will just leave you with these headings, and I hope that they will occasionally return to your minds as you think about the other talks that are going to be given in this series. Thank you.
Thank you so much for that. I didn't need to interrupt at all. So we will now move to Peter.
Thank you very much. I'm delighted that Sarah started off referring to Robin Gandy's comments on the 1950 paper. I think it's very important when reading the paper to bear those in mind. Turing is having a lot of fun. For example, when he's discussing what machines should be allowed to count, he says, "We wish to exclude from the machines men born in the usual manner." So he suggests that any engineering teams should be purely of one sex, i.e. not allowed to breed. He talks about God perhaps choosing to give a soul to a computer. And when discussing solipsism, he says it's usual to have the polite convention that everyone thinks. So when we talk to other people, we assume that there is a real person there, but that's just politeness. So, yeah, I don't think we should take the paper too seriously. It's got quite a lot of slips and inconsistencies, and Sarah has brilliantly brought out some of those that are implicit there. But what I do as a philosophical interpreter, probably more with early modern stuff than with Turing, but with Turing too, is to try to find a consistent interpretation that makes maximal good sense of what Turing is saying there. So what we call a charitable interpretation, and that's what I'm going to suggest here. So first of all, the paper is propaganda, as Gandhi said. What Turing is trying to do is make the case for the possibility of machine intelligence and try to persuade his audience to take that seriously. How do you do that in 1950? I don't think you do it by conjuring up the idea of robots. They're too far away. But a teletype providing textual responses is not far away. At least that's a very plausible thought experiment. And Turing points out that because language questions can concern anything at all, it's a great way of testing over a very wide range. You can do it on mathematics, you can do it at poetry, chess, and so forth. So I think it's a very good choice for that purpose. The other thing is, what Turing is trying to achieve by his test is to exclude bias by the interrogator. He knows full well that if you ask the average person in 1950, can a machine think? The answer is going to be, of course not. So what he does is he sets up the Turing test in such a way precisely that the biased interrogator doesn't know who is whom. And that's the crucial point. And if you look at earlier papers that Turing wrote, he gave a lecture to the London Mathematical Society in 1947, report to the National Physical Laboratory in 1948, and you can see the germ of the Turing test there. And he talks about fair play for the machines. We mustn't be biased against the machines. Okay, the other point I think Sarah mentioned is that...
1 minute.
1 minute?
5 minutes. Take away 4 is 1.
Oh, okay. Okay, sorry, I was assuming I had got the same as others.
Everybody gets 5 minutes.
All right, sorry, we started at 2. Yeah, all right. So he was keen on any imaginable digital computer. And he gives an example in the paper of a conversation, a viva voce examination, involving a sonnet writing machine. I haven't got time to quote it now, but do go and read it. It's a very impressive performance. And then when he is giving his predictions for 50 years hence, he gives 2 of them. One of them is very famous, and that's to do with how well something will perform in the Turing Test in 50 years' time. But the other one is to do with the change in our concepts, that by the year 2000, he thinks, the performance of computers will be such that we are ready, without deception, to attribute thinking to them. And I think that's probably where we are now. Thank you.
Thank you. Excuse me, to the people sharing. Not only did you volunteer to do this an hour ago, then you had to be told off by me. I'm very sorry about that.
That's right.
Alan.
Tell Steven to stop sharing his slide.
Stephen, Wendy would like you to stop sharing your slide if you can. Alan, would you like to say a few words to that? And then we might have time for one question.
1, 2, 3, 4. I have 6 words. One is, how about half-life for papers? Many of us have written papers in the past that have survived their usefulness, and yet they still are around. And this is one that really needed a fairly short half-life, because here we are, to my mind, more or less wasting time talking about the larger subject is important. I believe that's the reason that we're here, not this paper. And if we're going to talk about a Turing paper, the next one we should look at is the morphogenesis one. And the final word would be just, hey, don't forget about Bacon. He's already covered the ground about what's wrong with our thinking, and he includes most aspects of it and provides the initial clues for how to try and get, it's basically like noise removal. Every transmission of every kind that's sent around the internet is protected by various mechanisms, in spite of the many errors they have. Your CD, 1/4 of it is literally not music, but literally the bits that protect the music bits that are there and themselves. That is what we should be thinking about, is we need to build as Bacon pointed out, what we need to do is to build a set of methods that have a better signal-to-noise ratio than their individual components. And that is what science is. And I think that's what this subject needs.
Thank you. I will take one question, but since I brutally cut you off and now we're back ahead of schedule, I want to go back. I'll take the chair's privilege to go back to the sonnet.
Right.
You'll excuse me, Alan, this is probably not going to save the world, this question, but the
example that Turing gives.
The example.
Yeah,
so
okay.
Yeah. So tell us more about that, because I've had this, when I read that, I thought I could have this conversation with a student today.
Right.
And
So
it wouldn't be the student, it would be ChatGPT talking through the student.
Yeah.
I asked ChatGPT the question that is in the...
All right. We need to share with the audience how
Yeah.
that works, just as a reminder.
Right, so interrogator. In the first line of your sonnet, which reads, "Shall I compare thee to a summer's day? Would not a spring day do as well or better?" Witness, this is the computer, it wouldn't scan. How about a winter's day? That would scan all right. Yes, but nobody wants to be compared to a winter's day. Would you say Mr. Pickwick reminds you of Christmas? In a way. Yet Christmas is a winter's day, and I don't think Mr. Pickwick would mind the comparison. Final thing from the witness, I don't think you're serious. By a winter's day, one means a typical winter's day rather than a special one like Christmas. And I think the point here is Turing is saying, imagine something that could converse like that over the whole field of questions. How could you properly deny it intelligence? So, propaganda. Thank you.
Well, except that we've now got LLMs, which can answer that question quite well. Yesterday I asked ChatGPT, could I replace summer with winter, with spring in Shakespeare's sonnet number, whatever. And ChatGPT gave me a very good answer about it not scanning, about it not working with the semantic field of the rest of the poem. But I think LLMs really show that the Turing test is irrelevant because, again, they're just sequence prediction machines that are processing vast amounts of language and telling you what the most obvious thing that's going to come next is. Just because they can then convince you, or some people, that they are intelligent doesn't mean that they actually know what they're talking about.
I think Turing was being really polite. He did have the line in there about, let us not do silly things like having a race with a person in an airplane. So that's what happened with chess. Chess didn't prove anything because it was just brute force. And I think Turing, if he was being polite, and my colleague at Xerox PARC, William Newman, was the son of Max Newman and used to play Monopoly with Turing on Sundays. Turing would drop by their house to on his runs, and I don't think he would have ascribed this to Turing, but Turing might have said in that paper, most human beings couldn't pass the Turing test.
Yeah.
So I saw one hand there on the aisle. Is there somebody who can bring a microphone to there? Or just come and stand up and speak loudly.
I wanted to pick up on Alan's kind of skepticism about the value of the question. I wonder why, what good it does if we even get an answer. If that's an answer to passing the test, or if it's an answer to actually, can machines think, and we get an answer that's yes. I wondered what that changes about anything. Is it kind of an ethical demand on the machines that can think and for us and our behavior to them, or is it because it tells us something about what thinking is and the possibilities thereof, or does the answer not really matter at all?
Is that a question to me?
Well, it was your kind of skepticism about the worth of discussing it at all that made me think of it. But I'd be keen to hear from all of you if possible.
Well, so I'm basically a systems guy who dabbles in the arts. So my orientation is rather different than just being able to talk about something. I'm always interested in when you put something together, whether it's a sonnet or a theory, as to whether it holds together, and one of the things that people found out, for instance, Maurice Wilkes, who is a hero of mine, has a famous quote. He was going up the stairs, and it suddenly struck him as he put his foot on the stair that he was going to spend the rest of his life finding bugs in his own programs. And the reason he said that was they didn't think they would have bugs because they were all mathematicians. They all did mathematics. And they didn't realize how insecure the mathematical proofs were, which if you think of a good mathematical proof is actually much more of an act of engineering than it is of mathematics. Many PhDs in math have come out of bad, like Euler guessed theorems really well, but proved them badly. And so you could go to Euler and find a theorem, show why the proof was wrong, and come up with a better proof and get a PhD. And so I think the way people thought about themselves and what it meant to do something was greatly aided by having machines where you had to be more exacting to do things. And I think of philosophical theories as being of, the kind that actually aid thinking or are much more interesting as a commentary. And I don't think the philosophical aspects of Turing's paper are very interesting. They don't lead to much. Whereas I think of his two other great papers as being extremely important and extremely interesting. In fact, my whole career was based on his first one.
I think the simple answer is no, it doesn't matter. I mean, we could say they think, but unless you think that thinking equates to consciousness, free will, having a soul, any of the other sort of more philosophical questions, unless you think they equate, then we can just say that they're doing something that's called thinking.
By the way, I'm surprised that nobody has asked the question about the slide that has the the image of the globe stage inside the brain, which is where it is, because there's no color or anything else out. Everything is created by that guy. But surely somebody must have noted the resemblance of that to what might be called for in a biological brain to have something like consciousness. That there's a lot of things going on. It's not just presenting the outside world, it's presenting a simplification in a way so that another part of the brain, Marvin called this a B brain. So there's an A brain that's doing things, you need a B brain to look at it and so forth. And that is a really interesting thing that could be talked about the rest of this forum.
My two penneth. First of all, Turing knew nothing, of course, about ELIZA. ELIZA didn't come till 1966. It turned out to be much easier than people thought it would be to deceive people. So the Turing test is somewhat undermined by that. But the other point I'd make is something that Sarah said. I would strongly distinguish intelligent information processing from consciousness and autonomy and all the rest. Turing rather runs them together with his comments on solipsism, which is a shame.
Okay, I was given the very strict brief to finish on time, so I'm going to do that. I want to thank all of you, and thank Alan also for staying on stage, and Steven.
Yeah.
And for imparting, Steven, you imparted an enormous amount of information to us via the incredible technological advancement that is the PowerPoint slide. I hope that we have taken some small short steps in the direction of understanding this paper a little bit better. I know I have. And I thank you all for your attention, and the panelists, especially Peter, for joining us on such short notice. Thank you very much.